Welcome everyone. We have another office hours today, and after a brief pause, we are back in the EPF 7 office hours with AMAs with a special guest. So we have the series of calls where we invite some senior core developers, people from Ethereum, to tell you about their background, their work, and inspire you to work on the core development. So it's my honor to welcome here today Fredrik. Uh, Fredrik is the one of the leaders of the protocol cluster in Ethereum Foundation. Before he worked on the security team, making sure that not just the protocol but a wider Ethereum ecosystem has proper security practices. So I think he's a very important person and very interesting person to talk to and to meet. I hope you prepared some interesting questions for him. And welcome, Fredrik. So glad to have you here. And yeah,
Yeah, thank you, Mark.
of course. And before we get to the questions from the fellows, I just wanted to get started with a couple of my own questions, just so they can get to know you better. Maybe a bit about your background. I was wondering if you can tell us more about yourself, about your background before Ethereum. What did you do before your Ethereum journey? What did you work on before? What did you study? And what ultimately led you to work on Ethereum?
Yeah, of course. So yeah, I guess I've been around for quite some time now. Um, I s- so in high school I spent a lot of time studying like corporate economics and stuff. I figured that that wasn't really my thing because I was very interested in computers and IT and especially security. So after high school, I started working at this like IT support company where I spent a few times talking to people, helping them how to reset their internet and install their printers and a bunch of other stuff, which wasn't, I guess, the most interesting thing to do, but I think it was it was very useful in terms of like learning how to speak with people from a lot of different um, tech skill levels, which I think was very valuable afterwards. But yeah, after a few months, I left and I went to work for Blizzard Entertainment instead, and we worked on a game called World of Warcraft that I'm not sure how many of you have played, but yeah, we worked on that. I spent most of my time analyzing like large scale databases of what was happening in game, trying to prevent people from losing their money, stopping people that were abusing the game in various ways, such as automating it through bots and yeah, basically detecting and banning and yeah, getting funds back to people. So I guess in a way, like yeah, tracking what happened, just like you can do on chain today, which a lot of companies are spending time doing. So we did that, but it was yeah in the game basically. I spent 5 years there, 4.5, 5 years, and then I decided I wanted to focus more on, let's say, actual IT security. So I moved to another company, which was later acquired by Orange, which is this French company that has, I guess, services across the world with internet and stuff like that. But what I worked on was the European market, and we were focusing on delivering security services to critical infrastructure entities such as governmental agencies, central banks, airports, like boats, shipping entities, national healthcare system, police, and those kind of things. And that was pretty fun. The thing is that it's usually very slow moving. Like if you're a central bank, you probably don't want to use the bleeding tech. You want to use things that has been proved to be very stable and such. So I learned about this thing called, I guess, Ethereum in 2016, 2017, and that was really cool. I had heard about Bitcoin many years before, but it didn't really strike me as super interesting. Ethereum, on the other hand, was way more interesting because I could immediately see how it could be used outside of just being, say, a currency, because you could utilize, like at the time, things like Amazon Web Services, Azure, and Google Cloud and such was very prominently used in IT. And when I saw and read about Ethereum, I was like, this is actually something that could be utilized in similar fashions, or it could at least map the use cases to that, but it's more decentralized. It can provide censorship persistence and another type of security. So I got really intrigued in that, and I spent a few years looking into it, and also alt layer ones and other types of projects. And then Justin Drake ended up sending a post on X. I think this was in 2020. And he said that the EF was looking for security people to help with the merge, basically. So at that point, I reached out because this had become like my true passion. I spent some time, obviously, at work, but then my full spare time was basically spent on blockchain. So this was super interesting. It still felt a bit scary to take the plunge and move over. So I spoke with Justin many times, thought about this, but then I ended up joining, and yeah, I've been super happy I did. This has been the most amazing thing in my life, and super grateful to be part of it. Yeah, I've been I started by leading the protocol security team, and then I spent a lot of time doing things like the $1 trillion security initiative, and yeah, like Mario said, right now I'm leading the, let's say, the right side of the protocol cluster, and the right side consists of more of the engineering teams, which means security, Geth, networking, testing specifications, and DevOps or PanOps, basically. Acting as, I guess you can call it, a facilitator or whatever to those teams. Yeah, I mean, yeah, it was very big shoes to fill for sure. Martin has been around for ages and has a deep, like, he had an extremely deep knowledge about Ethereum. So, and then Ryan obviously as well, and many others. So, coming in without all the context that they had was obviously quite scary. But I mean, everyone. I think this is something that I have noticed is that everyone in this space is extremely willing and happy to collaborate and to share. There is no one who is like, "Oh, I'm not going to tell you this," or look down on you before you're asking because you're asking questions and stuff like that. This is something that people actually see as a positive thing. They want you to ask questions. They want you to learn. They want you to excel and advance. So yeah, it was scary at first, and like, it's very like it's extremely different, I would say, from working at a traditional, let's say, Web 2 or normal. I say normal, but a non-blockchain type of entity. There's a lot more. You need to do things on your own accord. You can't just sit around and wait. You need to figure out what's most impactful, and then end up doing it basically. And this can be a bit challenging for people in the beginning, especially if they're used to more of a traditional entity. But yeah, I think everyone that I've talked to, and this, I mean, this is holds true for me as well, has said that they don't want to go back to working at a, like, let's say, normal type of entity. They want to continue working in open source. They want to continue working with public good items because it is so much more rewarding, basically. Yeah. I think the some of the most um, exciting things for me right now is that we have made this kind of shift into, I guess, narrowing down what we are focusing on. So, with the mandate, we said we're gonna go all in and focus on censorship resistance, openness, privacy, and security. I think this has been it's been very good because now we have a better understanding of, like, these are the things that matter, and these are the things that we need to do in order to make sure that Ethereum can continue to thrive for 100 years or whatever. And with regards to the constraints, or constraints, there are. Well, let's start with the, I guess, challenges. And one of the challenges that we have a lot of things that we want to do, but there's only so much time to do it. And I think if you look at things like post quantum, which we don't really know when it's going to come, but from the sounds of it right now, Q Day is going to come in 2029. And what that means is that, if you're a blockchain or anything that's used in cryptography and you haven't prepared yourself or added or fixed your protocol so that you're not affected by this, then at Q day it's possible that someone could end up compromising the encryption and stealing funds, as an example. And this would obviously be very bad. So this is a big constraint, which means that we are constrained in time. And a challenge there is then to decide, okay, based on this constraint that we have 2029 right now. Who knows if that's going to advance or not, based on like AI advancements, which has been quite crazy in the last 2 years or even 1 year. And if you think about what's going to happen in another year. So we need to figure out, okay, what does that mean for future hard forks, as an example? How much can we fit into them? What kind of things should we fit into them when it comes to upgrading? So that is a concern. I think that's what's mainly on my mind right at this point at least.
Important problems to solve. I hope that fellows can get some inspiration, some of them working on related stuff already. And now that's my question for you folks. Like, what are your concerns? What are your questions? Guys, I hope you have some questions for Fredrik. Anything you want to chat about with him? I wanted to just do these first couple of questions to have some introduction and some overview so you understand who Fredrik is, what's his role and his background. But now I want to hear some of your questions. Please raise your hand and feel free to ask anything. Connell has a question. Go ahead.
Hello. I'm just wondering, as a somebody focused on security, if you think of like proof of stake security and a proof of stake attack, in the context of like all of the other stuff that can go wrong with Ethereum on the social layer, how much would you say that like the cost of a proof of stake attack, like how many billions it is, how would you describe like how much risk is there in terms of protocol security versus actually like ACD, like the ACD layer and the ability for other people to actually change the protocol or influence core development? Where would you say the bigger risks are?
I would guess, well, my gut feeling would be ACD, as in that is some potentially easier attack vector, because like you say, it requires a lot of money to do it. And even if you do it, you can do social recovery afterwards, which means that, it is, someone could have bought all of this ETH, spent it, and then the ecosystem decides to do a social slashing or social recovery to get past this, basically. While ACD is, you could do some, I don't know, when I think about security, I always think in terms of social engineering being the easiest way to basically breach a system. When we were doing pen tests and such, if we couldn't get in through any vulnerability in the system, we could always get in through a social engineering attack. Like, that was always possible. I think this is something that, I'm not saying like doing this on ACD is easy, because it's not. There are so many entities keeping track on this, and there are so many people, and it's open for everyone to listen to. So there are so many ways that this is being protected that I don't view it as a major risk. But it is, of course, something that we need to keep an eye on to make sure ACD is not captured in some way by an entity that is not looking for Ethereum long term, and B, that no clever social engineering type of attack is implemented in the protocol. So that's how I view it. Yeah, I guess I can also say that I have spent quite a lot of time working on, let's say, well, protocol security, obviously, but also things on the layers above. So I've been collaborating a lot with the Security Alliance and the Red Guild and other parts that are, working on security on the layers above. In case anyone has any questions about that.
Hey, yeah, I have a question. So what do you think protocol engineers should do more, if anything, to make sure that their changes and what they work on is not affecting the security of the protocol? Like, are there places that you recommend more focus, like spend more time digging into specs or read other clients' code, focus more on testing, like fuzzing, invariants? Any practice that you would like to see more?
I think the tests are probably some of the most critical stuff. They are the ones that catch the vast majority of issues that are introduced cross clients, and this is super important. We find divergences between clients quite frequently through tests, and this is let's say the first wall of defense that we do have, and then we do more specialized testing after that, or like reviews and audits after that, and that could be fuzzing, for example, as well as manual reviews and using LLM technology and such to review it. But yeah, the tests is something that we put a lot of value in and importance on, especially when something is introduced as an EIP, like making sure that there is a proof of concept, there are tests that clients that can implement. This can be, as a newcomer, it can be pretty hard, perhaps, to do this and think about all the edge cases and so forth. But like, to go back to what I said before, if someone do reach out to the specifications team or testing team, they are, from what I've experienced myself and from what I heard from others, they are very happy to help guide how to do it and come with feedback basically on, like, this engineering idea should have these types of tests. Maybe you say, I have these 10. They say, well, here are 5 more ideas that you can add, etc. And also speaking with people, getting their input tends to be very valuable in terms of thinking or like coming up with edge cases that it's hard, because it's very hard to think about every single thing by yourself. So yeah, getting more people involved in something is usually also a key to success.
Frederick, thank you very much for your time. I wanted to ask scope the security and your thoughts on machine checked proofs in Lean for the security purpose, especially considering some potential compiler bugs. As like recently, I saw a guy kind of he proved that 1 does not equal 0, for example, because of some compiler bug. Ooh.
Yeah, we haven't really started to look into it that much from a security point of view, from at least protocol security side. I think maybe Cody from the research side has started to look into it, but I'm not entirely sure. I don't know. I think, well, in general, this is probably how we would apply it to this as well. Is that, like I mentioned, we do these type of walls, or you can call them layers. In traditional security, you would call it the security onion, where you have these different types of ways of ensuring that things are secure. And if you only depend on, I don't know, formal verification to verify that something is secure, you're probably going to run into issues, because it's very hard to make sure that everything is completely specified and everything can be fully formally verified. And you can, you might, even with the specification, there might be issues with that. Like the specification could have bugs in it, which has been the case with the Ethereum specifications. At one point, we found a bug there. So like I said, it's about using these different types of security layers and not depending on a single one, but also using everything in the toolbox, because there is no silver bullet basically. So anyone who says, yeah, just formally verify and that's fine, I wouldn't buy that. There's a lot of stuff that people need to do to ensure that the client or whatever is secure. Yeah, I mean, the landscape has completely shifted, and like if you go back, I guess 2 years from now, we started using LLMs. I mean, this was before there was Cloud Code or Codex or anything like that. Back then, you either had the web page or the web GUI, or you had the API. And we ended up building tools that use the API to, for example, review PRs and things like that to find issues. And this was something that, proved quite successful. We found issues where if it had been merged, then it would have been a mismatch with the other clients. So there would have been a fork basically between the clients, and this was quite useful. And then things became more advanced. Cloud Code came out, Codex came out, and a bunch of other stuff. And I mean, the vast majority of things that we find today are through the use of AI tools in some type or form. We still do just manual reviewing from time to time, and especially when there's a hard fork. But the vast majority of stuff is found through LLMs, and the reason is that they can just hammer on for hours looking at things that might have been overlooked 4 years ago, 8 years ago, and that no one is really looking at now. But the LLM can just hammer at this and try to find the issues. They're not time constrained like humans are, so you can just launch 1,000 of them, have them just run your idea and do it for 24 hours until and see if you find something or not. I think this is going to become more and more advanced. I do think it's possible that we will be at a stage where vast majority of vulnerabilities will have been found. Maybe in a year from now, and I'm not saying this for like Ethereum, but for every piece of software, basically, that you would be able to basically reduce the amount of potential vulnerabilities down to almost zero. Still gonna be some issues, obviously, but not as it is today. And I think there are two reasons for this. A, the cybersecurity capabilities of the models are gonna improve, but maybe more importantly, more people are going to start using models to code, and those models will have the security awareness or security mindset built into it. There's going to be a progress, obviously. Like if you take a year, if you go back a year from now and you decided to code an application, just vibe coding it, it would have had vulnerabilities in it. But today, it's better. It might still have some issues in it. Maybe it adds an API key to the front end or whatever, but things are improving quite a bit. And I think a year from now, it's going to be even more. So I do think, kind of similar to cars, how AI-driven cars, the concept or idea is that there will be fewer accidents because there's going to be fewer humans actually driving, and the machines or LLMs or AI cars will be able to drive more safely, more coordinated, etc. And I believe we're going to be in a similar position with regards to code as well. Yeah, for sure. Like my main concern today is probably vibe coded software, and especially on it, like protocol critical software being vibe coded. Like that is what keeps me up at night in a way, because I don't trust it. But there's probably going to be a time when we can. I'm not sure when that is going to be, but for now, I definitely don't trust it. And I think another thing I should probably mention is, like, today the best models are, like, from a capability point of view, most likely closed source frontier models, but I do think there's going to be a shift there at some point. I think we're pretty close, but I do think we're going to be at a shift at a point where these open weight models that you can run locally, and you don't have to worry about censorship or privacy or other parts those will become more efficient, and yeah, I think that would also be extremely useful. Yeah, and let me reiterate that there are no stupid questions whatsoever.
Hi everyone. I would like to know that what is the security layers that you check on the Ethereum, and in details, if it doesn't take too much time for you. Yeah, that's the question. The layers of security. So one layer from the tag, so far I got that you check with the AI. And I would like to know more about the other layers that you, layers, tools and stuff that you use and for security. Thank you.
Yeah, of course. So yeah, like you mentioned, AI. I mean, that's a big layer today that we use, or we spend a lot of time on because it's very efficient. But yeah, we do spend a lot of time on other stuff too. One thing in particular is fuzzing, and fuzzing is actually very good on Ethereum because of the way it was promoted to have diversity, basically. So I guess to explain that a bit better, when you do fuzzing, what you do normally is that you take an application, you check what it can do, and you say, let's just throw a lot of stuff in as input into the application and see if we can make it crash, for example, or behave in a way that it shouldn't behave. And this is something that you can do with practically any application. With Ethereum, you can do something else as well. You can do something called differential fuzzing. And differential fuzzing means that you throw something as input into application A, you look at the output, then you throw the same thing into application B, and you store the output, and then you compare the both outputs. And if there's something different there, then something is strange, because they should behave in the same way. They should have the same. If they have the same input, they should have the same output, basically. So this is something that we can do with Ethereum. We have the the EVM, the Ethereum virtual machine. That one handles the transactions that come in, and if you send a transaction to one of the clients, it should behave the same way on all of them. So what we do there is that we do this thing called differential fuzzing. We have this tool called Go EVM Lab. It's got a public version that's kind of not been kept up to date. And then we have a private version that we have started to, I guess, utilize a bit more. But the public version is still available, and it is possible to run it against all the clients, etc. So that is something that we do quite a bit, and you can do this on the EVM. You can also do it on the consensus layer clients, like check how consensus is behaving between the clients. Like, do the clients behave the same way in every situation, etc. Yeah, the idea is that you just throw in a lot of randomness and make sure that they behave the same way. This has been super effective at finding flaws, because we do have so many different clients. It's like 11 clients total, and each client implements specification, but they also implement their own optimizations for the specification. And when they do these optimizations, sometimes things behave a bit differently. So yeah, that's what this is for. We also do manual reviews. So that means that you many times take the specification, you look at a client, and you verify that they have implemented it according to the specification. On top of that, other stuff that's being done is like providing grants to external entities or people to do security stuff. We do security coordination, which is also very important, like sharing best practices between the client teams or L2s or whatnot. Oh yeah, we have the bug bounty program. That is also one of the layers. Basically, the idea behind the bug bounty program is that if all the other layers fail, like we've missed to find something, then an external person can find it. And instead of them exploiting it, the vulnerability, they can report it to us, and they receive some rewards for it. I think the highest reward we have right now is, I should check so I don't say the wrong number, but I know we increased it just recently. So now it's $1 million for a critical vulnerability. So if someone finds a critical security vulnerability on Ethereum, then and report it to us, they would receive $1 million. So that's like the backup plan, you can call it, if all the other layers fail.
Thank you so much. I would like to know about the security that you check. Two questions, like the security that you check on layer 2s, first of all, and also how you check the security on the network level. I know that you mentioned the fast testing on the consensus layer. But I mean the network layer, just the network itself.
Yeah.
Thank you.
So we have for the network itself. If I misunderstand the question, please let me know. But like if we look at the network as in mainnet, then we have the DevOps team or PanOps team. They run a bunch of Sentry nodes and monitoring. So if there is let's say all of a sudden finality stops, or there is a drop in attestations, or there is an increase of missed slots, or all of a sudden like more than 10 validators are slashed, then we do have monitoring in place, and we have Sentry nodes, so we can detect these kind of things. And when that happens, I mean, usually that would happen around a hard fork, like all of a sudden attestations or proposals drop, and it could be because people haven't upgraded, or it could be that there is a bug in one of the clients, and because of that, that client stops proposing or attesting, or it could be that, basically those kind of things. So that's kind of what we do from a monitoring point of view there. For layer 2s, we don't particularly look into the layer 2s themselves. Most of the time they have their own security teams, so we focus on Ethereum mainnet. But we find issues in clients like Geth or Reth or other like Nethermind or other clients that L2s are using. So when the mainnet has been secured, we try to tell the L2s that you guys should be aware that there is a security issue with this client. You should do a release and get that out to your nodes, basically. But this is a bit of a sensitive thing because you can't tell the specific vulnerability to too many people, because then there's a risk that someone malicious sees that vulnerability and exploits it on mainnet or an L2 or whatnot. So there's a lot of coordination efforts being taken place there. And going back to AI has made this a lot harder, like significantly harder. In the past, we used to hide security fixes in releases. So you would have a release, you would have a bunch of code changes in them, and somewhere in there would be a security fix. But now this is a problem because in many cases an AI can figure out, like, has there been a security fix in a release, for example, or what is it? And that has shifted the way we have to do releases and announcements about vulnerability fixes, basically. So now we try to pre-announce in many cases, saying, at this time there's going to be an upgrade available. We urge everyone to upgrade as soon as possible, to make sure that the network is secure, basically.
Thank you so much.
Oh, you just mentioned the fasting test is very useful for like identify the issue in the protocol and some consensus client stuff. I'm curious about if you know about a simulation called like deterministic simulation test. So it is a test you can simulate all the states in your distributed system. I'm curious if you know about that, and how would this maybe there's some useful case in Ethereum, and what do you think of that?
Yeah, so I believe we have been using this system called antithesis. If I recall correctly, this is what that was basically doing. I don't know, have you heard about that, Jeff?
Okay, no
But
worries.
okay, no, I don't know if you heard about that, but yeah, basically we've been using that, and it's been useful, but from our experience, it's been extremely time consuming, and that is why we haven't really. Well, we ended up stop using antithesis for that reason, that it just took too much time. But I think with AI now, it's probably easier to automate this in a way that wasn't really possible before. But yeah, in the past, this was basically the case. But we also do things like, I don't know if you've seen Hive, for example, and other stuff that's basically also using these deterministic tests.
Okay, thanks.
Yeah, thank you very much. Always a pleasure to be here, and